For assessment of model, for assessment of framework in PLS, we have two main steps. We need to assess measurement model and structure. Measurement model or outer model, you remember, refer to relationship between items and constants. So in our framework, we have most of time, we have latent variable, right? And latent variable we measure indirectly based on some items and questions in our question. So first step is to assess reliability and validity or measurement model of these latent variables. Also we call constraint. So we need to assess in first step measurement model of our constraint or latent variable. But we discussed before that we have two main types of measurement model or two main types of constraint or latent variable. We have formative and we have reflective constraint, right? Also, we have composite formative constraint. This type of construct emerged recently in this recent year. But if say reflective dichotomy of reflective formative, composite also can be categorized under formative. So we have these two main types. And for these two main types of construct or latent variable, we have to apply different criteria to assess reliability and validity, right? So first step is assessment of measurement based on some criteria and based on types of latent variables, formative or. And second step is when we meet all criteria, when we assess reliability and validity of all constructs, then we can go to second step, that is assessment of structural. And assessment of a structural model, hypothesis testing is part of second step, assessment of a structural model. And the structural model actually refer to relationship between variables, right? So in first step, we have to assess measurement model. We have to assess constraint, reliability and validity of constraint. And in second step, when we establish reliability and validity, we can go to assess structural model and relationship between constraints, between variables, right? First, for reflective. For reflective construct, for reflective latent variable to assess measurement model, first step, we have to check using PLS. We have to check the criteria for these 4 steps. We need to check indicator reliability. We need to check construct reliability or internal consistency. We need to establish convergent validity, and we need to establish discriminant validity. Indicator reliability actually is something similar to loading that we assess in factor loading analysis. It's loading of construct for reflective lambda, for example. Loading of this item. So this loading should be higher than 0.7, right? So the loading should be higher than 0.7. In other words, Loading to the power of 2, squared loading should be higher than 0.5, means 50% of variance of item, 50% of variance of item should be common with variance of constraint. So it means at least this item represents 50% of variance of constraint. Common 50%. So this is loading power of 2, square of loading. So loading should be higher than 0.7 for indicator reliability. But actually loading between, as we discussed in factor analysis, loading between 0.5 and 0.7. Some literature says 0.4. But it's better to stick to 0.5. But still 0.4 to 0.5 can be acceptable if other criteria can be met. So if we have loading higher than 0.7, so it's fine, confirm. But if we have loading between 0.4 and 0.7, we need to check other criteria. If other criteria are greater than threshold, meet the requirement, meet the minimum value, minimum threshold, so we can keep this item. We can keep item with loading between 0.4 and 0.7. But if other criteria cannot meet the threshold, the minimum value, so we have to delete items with low loading until we reach to threshold. So for first step, we have to check loading, and loading should be higher than 0.7. If the loading is between these two values, so we need to wait and check other criteria. But lower than 0.4 should be deleted. Right? Okay. So this is first step for assessment of measurement model of reflective constraint. Second one is construct reliability. For construct reliability or internal consistency, we have the 3 criteria: composite reliability, Cronbach's alpha, and rho A. You have to report at least 2 of these criteria. It's better to report composite reliability and rho A in PLS. And these criteria all should be higher than 0.7. If you choose 2, both should be higher than 0.7. So this is for internal consistency or construct reliability. First one was for indicator reliability, right? So this one is for construct reliability. Third step for assessment of reflective measurement model is average variance extracted, AVE. And this AVE should be higher than 0.5. So for convergent validity, AVE should be higher than 0.5. So far, we check actually suitability of item, each item to measure a constraint. So we check loading, we check CRAB, current box alpha for each constraint, and we check AVE for each constraint. This is the formula for this one, internal consistency. This is the formula. Just to know, no need to do manually or memorize this formula. So software can calculate these parameters based on the formula for you. This is the formula for composite reliability. You can see a current box alpha is calculated based on variance, but composite reliability is calculated based on loading. So because of this, PLS preferred using composite reliability. And rho A is another criterion. Here we don't have formula for rho A. But you have to apply at least 2. And these 3 criteria, composite reliability, current box alpha, and rho A, always are between 0 and 1. They are not negative and cannot be higher than 1. Okay, so but to be acceptable should be higher than 0.7. This is formula for AVE. So here you can see again AVE's formula is a bit different with the composite reliability. Is again based on loading, and this value actually explain or present average variance of items, average common variance of items, average common variance of items. So this value should be higher than 0.5. So this is criteria for reliability and convergence validity. But we have another types of validity that we need to test, we need to check in measurement model assessment step. And this is the discriminant validity. Discriminant validity is different with the convergence validity. Convergent validity, actually, we check how converge items to establish, to create constraints. So we check convergence of items under each constraint. But in discriminant validity, we check divergence. We check distinction between different constructs to make sure that different constructs, different latent variables, different variables that we have in our framework represent different concepts. Are not representing same attributes, same concept. So we need to establish discriminant validity to make sure distinction between construct or latent variables involved in our framework, in our model. So you can see the concept of discriminant validity is different with reliability and convergence validity. So to check this discriminant validity, we have a few criteria. Fornell-Larker and the cross-loading are two famous criteria, but cross-loading is no more acceptable. Fornell-Larker is a traditional method to check discriminant validity. Is a correlation-based method, and based on Fornell-Larker criteria. Fornell-Larker criteria, and we actually calculate. For example, if we have two, if we have two constructs, for example, satisfaction, right, and loyalty. Oh, and here satisfaction in this table, satisfaction and loyalty. Correlation between satisfaction and loyalty, for example, is 0.56. For Fornell-Larker criterion, we have to check AVE. We have to check value of AVE with square of correlation. Square of correlation between this construct with other construct. Or we can check square root of. They are exactly same. AVE with square of correlation or square root of AVE with correlation of this construct with other construct. So here is a square root of AVE of satisfaction. For example, okay, satisfaction, loyalty, satisfaction, loyalty. So this one is 0.56. This is correlation. And square root of AVE is 0.75, for example. Right? And square root of AVE of loyalty is 0.81. Okay. We have to compare square root of AVE of each construct with correlation of this construct with other construct. Okay, let's add one more construct here. Satisfaction, loyalty, attitude, or expectation, for example. Okay, and expectation. Right? So correlation between satisfaction and expectation also is 0.67. Correlation between loyalty and expectation is 0.51. And the square root of AVE of expectation is 0.72. Okay. So to check Fornell-Larker criterion, we have to establish this table. Okay. Now square root is 0.75. Correlation of satisfaction and loyalty and expectation is 0.156, 0.67. So this AVE, square root of AVE, is higher than these two correlations. So this is acceptable. For this one, square root of AVE is higher than correlation. Correlation between loyalty and satisfaction is 0.56. Loyalty and expectation is 0.15. So it's higher. And also for expectation. So for Fornell-Larker criterion, AVE should be higher than square of the correlation or square root of AB should be higher than correlation with other constants. This is for if we get this value and the square root of AB is higher than correlation, we can establish discriminant validity. So discriminant validity is acceptable. Another one is cross-loading. Cross-loading, we compare loading with cross-loading. In factor analysis, we discussed cross-loading is loading of each item on other constraints. So the loading should be higher than cross-loading for this criterion. But as I said, it's no more acceptable. And the last actually criterion for assessment of discriminant validity that we developed recently is heterotrait monotrait ratio, HTMT ratio. HTMT ratio actually is something similar to Cornell law case based on correlation, but based on this formula. Correlation within a construct between items divided to correlation of item of this construct with other items. Okay, don't afraid of this formula. Formula is seems a bit complex, but actually the concept is very simple. Correlation between items divided to correlation of those items with other items. So this value should be low, this HTMT should be lower than 0.85 or 0.99. We have a different literature. Some literature say 0.85 and some literature 0.9. You can choose any one you want based on your result, right? So this is another criterion for assessment of discriminant validity. Okay, when you open software, you can see this window, a white window, including 3 stop windows. One is bigger one that later you will create your framework in this part. And here you have the project explorer. If you already created some project, you can see your project here. So you can see some of the paper or some of the board project that now I'm working. So always you can see your project that you already created. But if you haven't created any framework, model, or project, only you have a few options here. And so you can create your new project. Okay, to start using software and create new project, at the beginning you can see only 3 icons here in this menu bar, and only new project is active icon. So you can click on, you have to click on new project. Okay. So when you click on new project, you can name your project, for example, Quantitative Research Method class. Right. Project. So I create a project with this name, new project. So just click on it. When you click on OK, this icon will be appear here. There are 2 parts under this new project. One is one you can see with the model or diagram. So this one is to create your framework, this option. But before that, you need to import your data. You need to read your data and connect your data to this project, right? Okay, to import your data, you have to double click on first option. Here you can see a blue icon. Double click to import data. So when you double click on this icon, you will have to, okay, let me go to,
Do I use the data set that we have already cleared the missing value and the outliers?
yes.
Okay, all right, thanks. But it have to be CSV. We can't.
Yes.
Yeah.
Yeah. Now I explain, right? Okay. So if we go to this data set, okay. Here only I can see two data set, but if I change to, it's not possible to see other data set because SmartPLS software only can read CSV file, only can read file with CSV extension. So we can use CSV file, right? Okay, if here I have two file, but before that I need to show you how you can change to CSV file. Okay. Here I have all these files, right? Okay. But some of these files are in Excel format, some of them are in SPSS format, right? We cannot use SPSS format data set or Excel data set, Excel format for SmartPLS. First, we have to change to CSV. For example, if I open data set 50, nobody used this one, right? If I open this data set, okay, this data set I have in Excel format, right? Excel format. To be able to use in a SmartPLS, I have to save this data set, save as data set in CSV, comma delimited format. Okay, so here when you go to when you open file in Excel, you can save as this file as a CSV format. So if I click on this CSV or comma delimited format, data 50. So save it. Yes. Okay. Now if I go to software, this also can happen in SPSS. So if you have your data set in SPSS format, you can save as your file as a CSV. You have this option in SPSS. So you can convert your file to CSV file and able to use in SmartPLS. So if I go to software now, and again double click, okay, I should go again to, okay, here you can see now quantitative data analysis, data number 50. Now I have this data set. Before I only had these two. But now I save in CSV format and they can read and import this data file to my SmartPLS. So I click on this one and open. Okay, so now we have this data set, and in this data set for different indicators, you can see some descriptive analysis for each indicator. For example, mean value, median, minimum, maximum, standard deviation, cortices, and skewness. So for indicators, also software provide this descriptive analysis for indicator. So you can use this descriptive analysis from SmartPLS software if you need. Okay. Okay. So now we want to create our framework. When we want to create, when we introduce data, when we import data to our model and project, and when we click on this model item or pad model item with this icon, this white window will be open and we can create our model here, this white window. And here indicator will be appear. Right? Indicator will be appeared here. Okay. To create our model, for example, we want to see effect of 3 independent variable: community attachment, environmental attitude, and involvement on positive perception to our tools, right? So we want to create this model. Okay. To create latent variable, we have, when we come to this window and to create pad model, create our framework, we have some options in this menu bar. Two main options to start to create our framework is two options: latent variable and connect. Here, the quadratic effect and moderating effect are more advanced. We will discuss, and we will actually work with this moderating effect, but not this quadratic. This quadratic for nonlinear relationship. Okay, so the first option to create model is latent variable option. When you click on latent variable option, with this arrow, you click on this window, you can create new variable, new latent variable, right? So any number of latent variable, just you, based on your framework, only you need to click on this white window. But here we click 7 times, so we have 7 latent variables. But only we need the 4 latent variables, 3 IVs or 3 exogenous and 1 D. Okay, when you finish and you don't want to continue to create latent variable, you need to click on this select icon. Select icon. Okay, so now if you click, you don't have more latent variable. But here we have now we have 7 latent variable. Only we need 4, right? So we want to delete 3 extra latent variable. So again, right click, and when you right click on latent variable, you can get a few option here. Just click on delete, right click, delete, right click, delete. So keep 3 of latent variable. So when you click on latent variable, you can move to any place you want. Okay. Okay. Now I want to change the name because name of latent variable 1, 2, 3. Again, right click and rename. First one is community attachment. Second one is environment. Third one is economy. Okay. And dependent variable is positive. So now we have these 3 variables, but these 3 variables are without any items. Without any items. So for community attachment, we have to transfer indicator from community attachment to here. Okay. We transfer all CA to community attachment. So we need to select and drag and drop. Environmental attitude. Oh, we have only one here. This data set has some problem. So we have indicator in data set. We have indicator in data set CA1, CA2, CA3. But because of some issue, we cannot see indicator here. So this data set I need to explore and see what's the issue of this data set. But let me import another data set and use another data set that is sure is fine. Okay, if you import another data set, you can change active data set. If you right click, okay, you can select this data set as an active data file if you have more than one data set. So click on this one. Okay. Okay, now you can see EA1, 2, 3, CA1, 2, 3, 4, 5, 6. So you can see all. So I add this CA4. Also add EA1 and EA2. So here we have 2 times. Okay. So this data set is fine, but this one has some issue. So we need to check the problem of data set before starting analysis and creating our model. Economic gain, drag and drop. Also, you can find your variable in other way. If you didn't create latent variable here and just select variable, for example, involve item, for example, involvement, right? And drag and drop here. So new latent variable will be appear. So this is another way to create latent variable. Now you can change the name. And the positive perception, we have 5 items for positive perception. So now we connected items to construct. Two things. First, we want to change the actually position of items, because is now item cover relationship between constructs, so we don't want. So when you right click again, right click, you can see many options for each latent variable construct. So you can align to right, left, top, and bottom, right? Bottom, top, and right. So right is best position for this one. But still, your construct are red. Red means something missing. Still, your framework is not ready to perform. Your model is not ready because we don't have any connection between construct. Okay, so to connect between construct, we need to click on this connect icon. When you click on connect icon, you have to click on first and actually pointing construct, starting construct and pointing construct. So click on community attachment and positive perception. Click on environmental attitude and positive perception, economic gain and positive perception, and involvement and positive perception. So when you cannot have even one construct without connection, right? So you need to make connection between all constructs, right? At least one connection, at least one link. So now this is blue. Red changed to blue. Blue means your model is complete. Now you can perform analysis. You can run analysis for your model, right? Okay, this one. And when you finish this one, again, you need to click on select icon. Okay, select icon. It doesn't mean you have to connect all constructs together. At least one connection between one pair of constructs. For example, if you have another construct, negative perception here, okay, or support, for example, we create support line. Okay, you can see again all change to red, because for this construct, for support, we don't have any link. We don't have any link. So at least one link is necessary for support. For example, connect positive perception to support. So again, will be blue. Okay. But let me delete this one now. So now we created our model, including 4 exogenous construct and 1 endogenous, right? Okay. So when you create your framework, when you create your model, your pad model, this model in PLS, because PLS actually, traditional name of PLS is PLS pad modeling, not PLS SEM, right? So we call this model also pad model. There are some pad, and we call this relationship and link the pad, right? So we call the lambda or factor loading here is beta coefficient or regression coefficient here, we call path coefficient in PLS. So we have our path model or our model or our framework here, and we connect all construct, exogenous and endogenous. When we create our model, all analysis is done in this part. Here we have many different options for analysis. These options are a very advanced option, like PMIX for segmentation or multi-group analysis. In last session for moderator, I will briefly explain about multi-group analysis for you, because multi-group analysis is part of moderation analysis. We have the confirmatory tetrad analysis, importance performance, PLS predict. But for basic analysis, only we use these two parts, PLS algorithm and bootstrapping. But we have to run separately. First, we run PLS algorithm. Using PLS algorithm, we can get basic result for assessment of measurement model and structural model, part of result. But by performing bootstrapping, we can get full result for assessment of measurement model and structure. So first we need to run PLS algorithm. When you click on PLS algorithm, here there are some options. Don't change, just keep the default. For weighting scheme and the iteration, for all these criteria, just keep the default and the start calculation. Okay. So now you have result of analysis here. You have many different results, but you need actually part of this result for assessment of measurement model and structural model. What we need. Okay, before that, if you come to this part, in this actually window, we have one more tab, one more section. So in this tab, you can see some setting for result, and this setting can change. For example, here is path coefficient, beta coefficient. But if you change to total effect, here won't change because total effect and path coefficient here is the same. If, for example, we change to F square, okay? So you can see this will be different. So here there are some settings, but the most important part here is you can transfer your result as Excel file or HTML file or result for R programming. But we use Excel, result in Excel format. So if you click on Excel, just start export. This is for, let me create here a new folder. Results under assignment, and go to this one and click on save. So you can transfer all. Okay. So this is a result file, Excel file. There is a very good navigation in result of SmartPLS. So here you have different sheets. But in this navigation, if you click on, for example, path coefficient, but for assessment of a structure, assessment of measurement model, first we need to check loading for indicator loading, right? Okay, so if we click on this outer loading, click on show. So we'll be transferred to outer loading. So you can copy and paste loading in your result table from here. Right. But this is for reporting. But first you need to check this result in software. You can check this result in software before exporting your result. Okay, if you go to this part, this is PLS algorithm result. We perform PLS algorithm. Okay, here you have the final result and quality criteria here. Okay, first step for assessment of measurement model is to check indicator loading, right? Indicator loading. And need to check that all loading are higher than 0.7. So for this result, if you click on outer loading, okay, you can see this result. Green means higher than 0.7. Red means lower than 0.7. But red doesn't mean you have to delete it. If you have indicator loading, if you have loading between 0.4 and 0.7, only one, we have only one red here. Others are green, means all are higher than 0.7, right? Okay. So loading for all construct for environmental act for EA, EG, involvement and positive perception are okay. Only we have issue, maybe possible issue with this one. But in this stage, because this is higher than 0.5, we don't delete this one. We need to check CR, composite reliability, rho A or alpha, Cronbach's alpha, and AVE, right? And then decide about this indicator. So this is the first step of indicator loading and indicator reliability. For second step, we need to check construct reliability, right? Construct reliability using CR, Cronbach's alpha, or rho A. Two of them at least, right? Okay. If you click on construct reliability and validity, to check this criteria, we have to click on construct reliability and validity. So when you click on this construct reliability and validity, here you have result for Cronbach's alpha, rho A, composite reliability, and AVE. So you can see all are green, means these three are higher than 0.7, and this one is higher than 0.5. AVE should be higher than 0.5, and these criteria should be higher than 0.7. You have to report at least two. Better to report these two. Right? So based on the value of Rho A, composite reliability, and AVE, you can keep this item because this item is lower than 0.7, but other criteria for construct reliability and convergent validity are greater than threshold, greater than 0.7 and 0.5. So you can keep this item. So this is for reporting, loading, and the construct reliability or internal consistency, and convergent validity using AVE. For discriminant validity, here you have discriminant validity option in result file and also in Excel file. Again, here you have discriminant validity. Discriminant validity, this is Forner-Larker table. This is Forner-Larker table. So you can copy and paste this table in your report for Forner-Larker. And this is cross-loading, no need to use it. And this is HTMT or heterotrait monotrait ratio or method. Again, you can copy and paste this table, right, to your Word file to report. Heterotrait, monotrait, and Forner-Larker criteria. Okay. Also in software, you can see to understand and interpret in first place before writing your report. If you click on discriminant validity in software, okay, you can see Forner-Larker criterion, you can see cross-loading, you can see heterotrait, monotrait, right? So you have to report these two, Forner-Larker and heterotrait, monotrait. Okay. But how we can interpret again? To interpret Forner-Larker criterion, we have this information. Here is community attachment and community attachment, right? These two community attachment. So here in this cell is square root of AVE of community attachment. Square root of AVE of community attachment. So this value is square root of AVE of community attachment. This square root of AVE that you can find in diagonal, okay, you can find in diagonal. So this one is square root of AVE of economic gain. This one is square root of AVE of environmental attitude. This one is square root of AVE of involvement, and this one square root of AVE of positive perception. We have to compare this square root of AVE of each construct with correlation of this construct with others. Okay, this is a square root of AVE. This one is correlation of community attachment and economic gain. This one is correlation of community attachment and environmental attitude. This one is correlation of community attachment and involvement. And this one is correlation of community attachment and perception, right? So square root of AVE is 0.76. Correlation is 0.25, 0.6, 0.469, and 0.478. So square root of AVE of community attachment is higher than square root of AVE of community attachment is higher than all correlation, right? This one, this is correlation, this one is correlation, and this is square root of AVE. For this one, square root of AVE. But here you can see values only in lower part of this table, not upper part, because the value is exactly the same. Yeah, this one is correlation between community attachment and economic gain. If we put this value here, doesn't matter we say correlation between community attachment and economic gain, or economic gain and community attachment, right? So only we have values correlation in this lower part, not upper part of this table. We have values under this diagonal. So this is correlation for economic gain and community attachment. So again, this square root of AV is higher than this 3 and this one. This one is higher than this 2 and this 2. This one higher than this and this 3. And this one is higher than this 3 correlation. So we can establish discriminant validity based on Forner-Larker criteria. So you have to copy and paste this table and discuss this one. I uploaded, I think, a few papers to see for reporting PLS result. How we need to discuss assessment of measurement model and structural model when we use PLS. So you can use those papers. Okay, but it's exactly same as my explanation here. So for this one, you have to discuss this square root of AVE based on Forner-Larker criteria. Another method for discriminant validity is heterotrait monotrait, or HTMT. When you click on this one, okay, you can see here is all green, right? All green. So this is HTMT value for community attachment and economic gain, right? This is HTMT for economic gain and environmental attitude. This is HTMT for environmental attitude and involvement. So HTMT, the value of HTMT should be lower than 0.85. This is the best one. This is the best one. And also, if it's lower than 0.9 is acceptable. But here you can see all HTMT values are lower than 0.85, right? So we can establish discriminant validity, or discriminant validity is acceptable based on both Forner-Larker criterion and HTMT ratio, HTMT value, right? So this is for discriminant validity. You can get the result from Excel file. You can copy and paste this Forner-Larker criterion and also HTMT to your report.